Assalamu alaikum. My dear students, this class is for 11th subject chemistry and our today's topic is physical equilibrium and its types. As in our last lesson, we have discussed the chemical equilibrium, the factors that affect the chemical equilibrium. In today's lesson, we will have a look in on this physical equilibrium and its types. First of all, what is physical equilibrium? In the chemical equilibrium, we have mentioned it there. Chemical equilibrium is that state of a system in which the concentration of the reactants remains the same as that of products. But in case of this physical equilibrium, it is that state of a system. It is defined as the equilibrium which develops between different phases or between different physical states having different physical properties. In these processes, there is no change in chemical composition. Chemical composition remains same. It represents the existence of the same substance into two different physical states. In this physical equilibrium, the composition remains the same. There is no change in the chemical composition. But what happens? Only it represents the existence of the same substance in two different phases, in two different physical states. The physical equilibrium can be either phase equilibrium, solute solid equilibrium, gas liquid equilibrium. Phase equilibrium, types of physical equilibrium. Phase equilibrium. What is phase equilibrium? At the temperature of 0 degree centigrade, the number of water molecules becoming ice is equal to the water molecules as ice melting to form liquid water. That is, when the at this temperature at 0 degree centigrade, the number of water molecules which turn into ice, when that is equal to the number of water molecules which melt to form liquid. Rate of freezing water is equal to the rate of melting of ice. Thus, there is an equilibrium between solid ice and liquid water. That is, how many molecules of ice melt to form liquid water is equal to the number of water molecules that freeze to form ice. And in that case, when the number of molecules are equal, at that time we can say it is in this equilibrium state. The number of molecules of a liquid becoming vapor will be equal to the number of molecules considering into liquid in a closed container. And at this time, rate of evaporation of liquid water is equal to the rate of condensation of water vapor. So liquid phase is in equilibrium with its own vapor phase. That is, the same substance exists into two different states where the chemical composition remains same. That is, this water, it has two states here, liquid state and gaseous state. The number of molecules turning into gaseous state is equal to the number of molecules turning into liquid state, and this is the equilibrium state. Now, solute solid equilibrium. When a solute in a saturated solution is in contact with undissolved solute, that is, a solute in a saturated solution is in contact with undissolved solute, the number of molecules going or depositing out of the solution is equal to the number of molecules interning from the solid into liquid. That is, Same number of molecules are interning from the solid into liquid as the number of molecules are going out from the solution. So the solute in a solution is equilibrium with the undissolved solute. This is solid solute equilibrium. Now gas liquid equilibrium. Gases that do not react with liquid. Those gases which do not react with liquid may dissolve directly related to the pressure in the liquid. In a closed container, there is an equilibrium between the gas inside the liquid and the gas present above the liquid. If we take the example of our soft drinks, carbon dioxide gas in the liquid is in equilibrium with the gas in the empty space of the container. Carbon dioxide gas, again I mention it, carbon dioxide gas in the liquid is in equilibrium with the gas in the empty space of the container. In our these soft drink bottles, we have some empty space above, and in this liquid there is carbon dioxide gas, and that carbon dioxide gas is equal to, that is in equilibrium with the gas that is in the empty space of our bottle. Examples of physical equilibrium. Example of solid liquid equilibrium. Consider ice and water in a perfectly insulated thermos flask at 0 degree centigrade in an open atmosphere. There will be no change in the level of water and quantity of ice, which implies that rate of transfer of molecules from water to ice is equal to the rate of transfer of molecules from ice to water. This is simple example. The rate of conversion of ice into water and water into ice, that remains same, and that is termed as equilibrium. Hence, we conclude that this system is in a steady state. This can be represented by the following equation. The rate of melting is equal to rate of freezing. Liquid gas equilibrium. Take distilled water in a closed container and start heating. यहाँ पे हमें क्या करना है, वी हैव टू टेक दिस वाटर इन ए क्लोज्ड कंटेनर. यहाँ पे जो सिस्टम हमारा हो ओपन सिस्टम नहीं होना चाहिए. द वाटर कन्वर्ट्स टू वेपर. After a certain time, we will observe that the level of water becomes constant, implying that there is no more conversion of water to vapor and vapor to water. We can say that rate of evaporation is equal to the rate of condensation, thus achieving a steady rate. That is, there remains a balance. This can be represented by this equation. So in the whole process, what we observe that the rate of evaporation is equal to rate of condensation. Solid vapor equilibrium. This kind of equilibrium can exist only in the case of sublimate, that is solid directly converts into vapors. Consider heating of solid iodine in a closed container slowly. The vessel is filled with violet colored vapor and the intensity of color increases with time. After a certain time, the intensity of color does not change with time. This implies a steady state is attained where the rate of sublimation of solid iodine is equal to the rate of deposition of iodine vapor. So, rate of sublimation is equal to rate of deposition. Now, already we have discussed this dynamic equilibrium. Here, we will see what is the difference between static and dynamic equilibrium. When the two opposing forces are operating simultaneously and independent of each other, the two states are formed with the interchange between the two states. The states are said to be in dynamic equilibrium. When two opposing forces are operating on a body simultaneously and are independent of each other. Then two states are formed. The states are said to be dynamic equilibrium. A double-sided arrow represents the dynamic equilibrium. Depending on the composition of two states, the two equilibriums, namely physical or chemical equilibriums, are defined. Dynamic equilibrium can be defined as that state of a given system in which the reversible reaction taking place in it stops, changing the ratio of reactants and products. But there is movement of substance between the reactants and the products. This movement occurs at an equal rate and there is no net change of the reactant and product ratio. So, in this dynamic equilibrium, where the reversible reaction taking place stops, changing the ratio of reactants and products. But there is another thing, that is there is net movement of substance between the reactants and the products. On one hand, in this dynamic equilibrium, the reversible reaction stops, but movement of substances between reactants and products takes place. And this movement occurs at equal rate where there is no change in the ratio of this reactant and products. We have already discussed this dynamic equilibrium. Here we will see the difference between static and dynamic equilibrium. Static equilibrium refers to a condition where the reaction occurring in a system is completely stopped. It is halted and there exists no movement of molecules between the reactant and the products. So we can say there is the complete stop of reaction. The reaction does not occur at all in this equilibrium. The movement does not take place. So if the forces acting on an object cancel each other, in addition to the constancy of content and composition, no movement of object takes place. This is static equilibrium, and the points of difference between this dynamic equilibrium and static equilibrium are: in case of this dynamic equilibrium, it is reversible in nature, but the static equilibrium is irreversible. In this static equilibrium, the movement totally stops. This equilibrium implies that reactants and the products are still participating in chemical reaction. In case of static, there is no further chemical reaction in the system. And in this dynamic equilibrium, the forward and the backward reaction rates are equal. In static equilibrium, the forward and backward reaction rates are zero because reactions do not take place. And the dynamic equilibrium takes place only in closed systems, and this static, it can occur in both open and closed systems. However, the resultant force acting on both of these types of equilibria in a system is zero. The net force acting on both types of equilibria, whether it is static or dynamic, is zero. Generally, neither of these types of equilibria display visible changes.